Hey guys, we are still in chapter 1 and we are definitely looking at expressions, equations, and functions, and we're checking out the distributive property today. So this ought to be fun. Not a bunch of properties, just one. Our vocabulary words are as follows: like terms, simplest form, the word coefficient, and the property called distributive property. I'm going to look at each one of these terms on a different screen, so let's take a look. Like terms are terms that contain the same variables with corresponding variables having the same power. So for instance, if I were to, let's say, write 2x squared plus 4x minus 5x to the third power plus 3x. Only two of these are like terms, and that's 4x and this positive 3x. These guys are unlike. I sometimes call them like cousins. They're cousins, but they are not a part of the same household, if you know what I mean, because this is to the second power and this is to the third power, where both of these to the first power. So like terms, these are not like terms. Got me? We could also have terms that have more than one variable, so 2xy plus 5xy minus 7xy. You can actually simplify this because all of these are the same term. Let's look at the next vocabulary word. The next word is simplest form. An expression that contains no like terms or parentheses is considered in its simplest form. So for example, if I were talking about going to the store, so I went to the store and I spent $2, and then I had to buy a backpack for one kid, and then the other kid said, oh, I need a backpack too, and then my husband said, buy an extra one, so I bought 2 more backpacks. This would be an expression that represents how much I spent. Now, this is not in simplest form because I've got 2 like terms. So when I join these 2 like terms together, 1b plus 2b's is going to give me 3b's. I spent $2 and I bought 3 backpacks of identical price, and I got 3b. What this is showing me, friends, is that now that there are no like terms, I have simplified it enough. There's nothing that's alike. There's nothing that I can collapse and simplify. So now it's in its simplest form. Our next vocabulary word is coefficient. This refers to the numerical factor of a term. So remember, we had terms like 2xy, or a term would be 3y squared, or maybe 7z. These are all terms, but the numerical factor, so the number that's next to it, the number in front of the variable is sometimes how I say it, is referred to as the coefficient. So the coefficient is a number, and it's usually being multiplied. It is being multiplied with a variable or variable term. And finally, we've got distributive property, which looks more complicated than it is. You guys are used to it. Basically, if you have A times some B plus C situation, you can, if you can't simplify what's going on inside, or even if you could, you can choose to rewrite this as A times B plus A times C. Okay, so that's what the distributive property is all about. So for instance, I'm going to give you an example. If I had 3 times 2 plus 5, you guys can quickly do this and say, well, 2 plus 5 is going to give you 7. 7 times 3 is 21, and you'd be correct. But if we use the distributive property, we're going to see that we get an equivalent expression as well. So this distributive property tells me that I can multiply 3 times 2 plus 3 times 5. I'm really used to using arrows when I do this. So 3 times 2 plus 3 times 5, and that's going to give me 6 plus 15, which, surprise, surprise, is 21, right? You expected that. And so some of you right now are thinking, why on earth would I do it that way when I can just do it the simple way? Well, because we're dealing with algebra, and from time to time, we won't be able to simplify within the parentheses because we might have a variable. And here is another way that we can look at it, and this is going to be important too. This is just saying that if you have B plus C and then A's on the right side of the parentheses, you can still look at it as distributive property. You can distribute back in, and you can also distribute over subtraction and addition. All right, so we only distribute over subtraction and addition, and it doesn't matter if it is to the right or to the left of the parentheses. As long as there's no sign between the parentheses and the number, then you're going to distribute throughout the parentheses. All right, so now we've got a quick one, mental math. Use the distributive property to rewrite this. I always find these problems a little bit weird, to be honest, because I don't know if you would intuitively think of mental math, but what what the text is alluding to is the fact that 7 times 49 is hard to do in your head. But if you were to look at this as 7 times 50 minus 1, it suddenly becomes easier, because 7 times 50 is pretty easy. You just get 350. And then 7 times 1 is obviously easy. You get 7. So watch how I'm rocking the distributive property, right? So I rewrote this statement. I have now an equivalent statement rewritten using the distributive property. So then now if in my head I'm thinking about it, well, 350 minus 7 is going to give me 343. So you could have done this using the distributive property. Most people probably wouldn't, but that's what they're alluding to on some of the assignment problems that you'll have. Over here, algebraic expression, we're going to rewrite each expression using the distributive property, and let me go grab some expressions for you. There are the expressions, my fault. So here we're going to rewrite using the distributive property, and the distributive property is fun. I'm going to multiply 7 times that and 7 times that. So when I rewrite it, I could take the time to write 7 times 3w minus 7 times 5, or I could just write it as 21w minus 35. Let's do the same thing here. Notice this is a situation where the number that we're multiplying is actually on the right side of the parentheses and not the left. So we're going to just multiply through each term within the parentheses, and we'll get our answer. 4 times 6v is 24v squared. That was 4 times 6v squared, pardon me. 4 times a positive v is plus 4v. And 4 times a negative 3, which I know looks a little crazy, but it is negative 3, is a negative 12. And stick a fork in me, we're done. That's it. That's it. All right, so combining like terms, this looks like another place I avoided to put an equation. Just wait. Okay, there we are. All right, so here are our expressions, and we're going to simplify. I look at 17u and 15u. They are pretty much identical in terms of their variableness. It's a u to the first power. So these are considered like terms, so I'm going to join them together by adding 17 plus 15, and I'm going to get, so if I have 17 u's and then I have 15 u's all together, I have 32 u's, and I put it just like that. That's not u squared. I want you to think about it as if there's 17 u's and 15 u's, and you bring it all together, you still have 32 u's, not u squared. That's different. Here we have exponent on this t value, and then we have t to the first power and t to the first power. These guys are the common or the like term, so these guys we can bring together. This guy we can't. So 6t squared gets rewritten, and now we're going to do the operation that's here. It says 3t minus a t is going to leave me with 2 t's, so I'm going to be left with a positive 2t, and that's it. All right, so that's not too bad. We have one last problem in the assignment. You can go ahead and pick that up from your packet. This last example, that is example 4, we're going to write and simplify each expression. So we're going to be given an expression and we're going to simplify it. Use the expression twice the difference of 3x and y increased by 5 times the sum of x and 2y. It seems like a lot. Let's take it and unpack it slowly. So use this expression. Okay, so here's the expression. So use this expression. So twice the difference. So twice means 2 times. So 2 times the difference. So I'm talking about the difference of something. So twice the difference. The difference of what? The difference of 3x and y. Okay, so I've got that. So let me make sure that felt comfortable. Use the expression twice the difference, 2 times the difference of 3x and y. All right, I'm feeling good about myself. Now I'm going to increase that by 5 times the sum. So increase means to add by what? 5 times something. 5 times the sum, 5 times of something. So I'm going to put a parenthesis there. So I'm increasing it by 5 times the sum of x and 2y. Sum means to add. So we get x and 2y like that. That is what this expression is. Now we're supposed to actually simplify the bad boy. So I feel confident that we got the right expression. Simplifying, we're going to rock our distributive property, multiply through by 2 here, and I'm going to get 6x minus 2y. And then here I'm going to multiply through by this positive 5, and I'll get positive 5x plus 10y. The final thing I need to do is join like terms together. And as I look at this problem, I see I have 2 pairs of like terms. The first pair would be this guy and this guy, the x terms, and the next pair would be, let's see if I can use this one. This guy, that's not even different. That looks the same, people. It would be this one and this one, okay? So we've got these two are the same and these two are the same, and when I simplify that and I write it out, I end up with my final answer of 11x. Negative 2 plus a positive 10 is going to give me a positive 8y, and that's it. Now we have come to the end. I hope this made sense. I hope this wasn't too bad. It wasn't as intense as the last video, but it did have a very important property. You are going to use distributive property all the time, so make sure you commit it to memory. If you need to, if you're like me, and for years, I really had to every time draw the arrows. Draw the arrows so you can remind yourself to multiply by both. Common mistake, people multiply by one term and forget the other. Guys, I can't wait to see you. Definitely let me know if you have any questions, and take very good care. Bye-bye.